The arithmetic instructions in 8085 can be classified as addition instruction, subtraction instruction, and increment or decrement instructions. Uh, let's first look at the addition instructions. And the first instruction of its kind is ADDR. So what is ADDR? This instruction will add the content of accumulator with the content of the given register provided in the instruction, and the sum is uh, stored back in the accumulator. So for example, let's take an example of ADD V. So this instruction will add the content of accumulator A with the content of register B, and the sum is stored back in the accumulator A. And since this mnemonics doesn't mention about carry or any other flag, so this doesn't care about carry or any other flag. This will simply add the two registers, and sum is stored in the in the accumulator. Okay. And the second instruction is add So it involves m. So as we have discussed earlier, whenever there's a m in the instruction, it means that uh, it represents a memory location which is pointed by HL pair. So in the operations, you will see that there is ICL enclosed by this first bracket. This enclosure of first bracket indicates that this is not the content of HL pair, but the memory location which is pointed by HL pair. Okay. Say let's take an example. That say for example, we have this H. This is H. H contains, say for example, say what 1 2, and this L register contains 3 4, and in the memory locations, in the memory we have address called 1 2 3 4, and there's a content of this memory location. So this instruction is doing is that this HL pair is pointing to a memory location which is uh, equal to the content of the HL pair, right? So the address of this memory location equals the content of this HL pair, and the content of that particular memory address should be added with the content of accumulator, and the result stored in the accumulator. Okay, this is what this instruction is doing. So okay, the third instruction type is ADI data. So if you look at the mnemonics, it has I. So if you have I in the mnemonics, it means that there's some immediate data involved. Okay, there's some immediate data involved in the instruction. So this instruction will add the content of accumulator with the 8-bit data, and the sum is stored back in the accumulator. So for example, let's say we have ADI A5H. So what this instruction is doing is that this A5, this 8-bit data will be added to the content of accumulator, and there's a sum, and the sum is stored in the accumulator. Okay. What about this instruction? So let's look at the mnemonics. This is AD, add, and there's a C involved. So this C means that we have to consider the carry flag also. Okay, if the carry flag is 1, we have to add 1 to the sum, or if it's 0, nothing changed. So this instruction is doing is that the content of accumulator is added with the content of the register, which is provided in the instructions. And in above of that, we have to consider the carry flag also. Okay, so all these things will add up, and the sum will be stored in the accumulator. So we have to know that the accumulator is the default register for storing data. What about this? Okay, we have this 8 with C. C means carry, and we have M. So let's take an example that A, D, she. Okay, we don't need to take an example. So this instruction is doing is that so this instruction is doing is that the content of accumulator A will be added to the content of memory location, which is pointed by HL pair. And since there is C in the mnemonics, we have to take care of the carry flag also. And the sum of all this will be stored in the accumulator. And the last instruction of this addition instruction is ACI data. So ACI means A represents addition, C represents carry, I represents immediate data. So there must be an immediate data. So this immediate data, which is provided in the instructions, should be added with the content of accumulator, and we have to take care of carry flag also. If there's if your carry flag is set, we have to add 1 at the end or if it is 0, we can just discard it, and the final result is stored in the accumulator. So in all these instructions, what we can see is that it is arithmetic instructions. All flags are affected. Okay, all the 5 flags are all affected. In the subtraction instruction, likewise in the addition instructions, we have this sub R. Sub R means subtract this register, which means that we have to subtract the content of the register provided in the instructions from the content of A, and the difference is stored in the accumulator. Likewise, in the sub M also, the content of the memory location, which is pointed by HL pair, should be subtracted from the content of accumulator, and the difference is stored in the accumulator. Likewise, this is all the same. SUI subtract immediate. So the immediate data provided in the instruction is subtracted from the content of accumulator, and the difference is stored in the accumulator. SBB subtract R. SBB means SUB or SB means subtraction, right? So if there is additional B, like in the addition instruction, if there's C, right? If there's C, it means that carry is involved, right? Carry, we should take care of the carry. So in the same way, in the subtraction instruction also, if there is additional B, right? This SB represents subtraction, and this additional B represents borrow, right? Borrow. So we have to take care of the borrow since there's no borrow, since there is no uh, dedicated borrow flag, this borrow will use the carry flag. So instead of just subtracting uh, the content of register from the content of accumulator, we have to take care of the carry flag also, since this instruction mm, talks about the borrow also. Okay. Likewise, SBBM. So since there is additional B, we have to take care of borrow also. Okay. I think you will understand this instructions. This also. SBI means subtract emitted data. So we have to subtract this emitted data from the content of accumulator, and uh, we have to take care of this borrow also. And what we can see is that likewise in the addition instructions, all the flags are affected. Okay, all the flags can be changed according to the results. And we have this increment and decrement instructions. Okay, this, what is this? INR R. INR means increment R. So this instruction increments the content of the given register by 1. Increment M means increment the memory location, and increment the content of memory location which is pointed by HL pair by 1. Okay. Likewise, we have this INX RP. So this X represents the extended pair. Okay, this X represents in extended pair, and in this instruction there must be a 16-bit number. So for example 1 2 3 4, since it uses the extended register pair. So this is 16-bit number, and the 16-bit number is increased by 1. Likewise, decrement DCRR. So it should decrement the content of this accumulator, not accumulator, content of this register by 1. Likewise, this also it will decrement the content of memory location which is pointed by HL pair by 1. Likewise, this also DCXRP. So it represents extended register pair, and the extended likewise in this instruction. Likewise, this instruction will decrement the content of the extended register pair. Okay, if you look at the flags, this increment R, increment M, this decrement, this. Okay, increment decrement of this 8-bit data. Okay, it doesn't generate any carry, right? So this increment decrement are mostly used for counting purposes, and it doesn't need carry to generate. Okay, it doesn't affect carry flag because it doesn't need. And in these instructions, INX RP and DCX RP. Okay, in these two instructions, no flags affected. Why no flags affected? Because in these instructions, it is dealing with 16-bit data, right? So in the I0 I5, the 16 bits are used for addresses and not for data, right? So these 16-bit numbers are not used for any kind of operations in the sense that operations which involve data, they are they're exclusively used for addresses. So we don't need any flags to affect it, since these numbers are used exclusively for data purposes. So for example, these instructions are used to uh, increment or decrement the address, right? And not the data to be manipulated. Okay, I think this sums of the arithmetic instructions in 885.